Hello. This is a copy of the lab that we're going to be working on today called Warming Up. And it's a lab that is going to be looking at solar energy and the effect that it has on the heating up of our world, or in this case of water. One of the things that we're going to talk about is the fact that differing materials are going to maybe reflect and prevent heat from the sun from warming up water, or perhaps some things might actually encourage the heating up of things. So the first thing we need to do is to fill one of our cups here that we have already painted and made black with water, and we want to know how much water that this cup holds. So we're going to measure it in our graduated cylinder here, and it says that it takes 195 milliliters. So we're going to record that volume here. 195 milliliters. Okay. The other thing that we need to do is to measure the top of our cup, the diameter of it. And so we're going to use our centimeter ruler here. Notice it says 7.5 centimeters. 7.5 centimeters. And we want to be able to convert that into meters. So what I did was to write down our King Henry died unexpectedly drinking chocolate milk to help us remember how to convert. And we want to convert from 7.5 centimeters into meters. That means we're going to take our decimal and move it 2 places to the left. And so 0.075 meters is the same thing as 7.5 centimeters. So 0.075 meters. Okay, I've already done this for us. We have foam cups, 1, 2, 3, 4, and paper cups that have been spray painted black and allowed to dry. I have filled up our scenario, and it's actually been going now, so our time is ready to be able to take our measurements. We have cups that have been insulated by some paper, and we're using a light, normal incandescent light bulb to be a model of our sun. So what we're going to do here is to finish filling out this page. We have a thermometer here that's going to measure our room temperature. And so it's 15, 16, 17 degrees Celsius. And we have water that's already that temperature that that I had filled in to the cups. It also mentions here that we're going to fill each cup with as many dark colors of food coloring as we can, so I already did that. We want the water to be dark, and like it says, filled to within 1 centimeter of the rim. We have one of our cups that's been filled with, or that's been covered with saran wrap, one with foil, one with a glass plate, and one that has nothing. The thermometers have been in there, like it says here, for a total of 30 minutes. And so our starting temperature of the water, the temperature that I measured when we first began, 17 degrees Celsius for each one of these. Whoops. And 17 degrees Celsius. And now what we're ready to do is to measure the temperature at this point after 30 minutes and see what kind of change that we have encountered. So our first one, we want to keep them in the cup while we're reading. Looks like 16 degrees Celsius, so it's a little bit cooler. The second one, our foil, I'm going to read here, and it is 15 degrees Celsius. Our glass plate here, the temperature is 15, 16, stayed the same at 17. And the cup that's open to the sun is actually at 16, 18 degrees Celsius. So using our formula here, says to take our end temperature minus our start temperature. So 16 minus 17 is going to be a negative 1 degrees Celsius. 15 minus 17, negative 2. 17 minus 17 stayed the same at 0. And 18 minus 1, a 1 degree temperature change. So you're going to discuss here how the temperatures changed in each of those 4 cups. You're just going to write this in words. So you should have 4 statements there. Okay, we're ready now to go ahead and do some of the other calculations from this particular lab. So what we're going to do is to use the fact that we have had 30 minutes pass, which is the same thing as 1800 seconds, and we have already calculated our area, and what we're going to do is to use some of these things to be able to fill in that formula, okay? You're going to answer the questions at the top of the page. A real-world effect of plastic wrap in glass. They suggest you checking in your textbook, chapter 18.12, to help you with that. Okay, to calculate our area, pi is 3.14 times our diameter, and the diameter is squared. That means it's times itself, right? So 0.075 is what we're going to use there. 0.075, we want to square that. And then we're going to divide by 4. So I'm going to do the math here quickly. So 0.075 times 0.075 is this number, 5.62 times 10 to the third. We want to divide that by 4, and we get 1.4 times 10 to the third. And now our formula says to multiply by 3.14, and we get 4.4 times 10 to the negative third, right? So 4.4 times 10 to the negative third, and that is the same thing as 4.4, and you're moving the decimal point 3 places, 1, 2, 3, and adding zeros there. So it says to record our answer to 3 decimal places. It's the same thing as 0.004 square meters. Okay, we're going to use that later on. Also, it says to record the mass of the water based on the volume. Remember that 1 milliliter is the same mass as 1 gram. So if we had 195 milliliters, that would be the same thing as 195 grams. We're going to come down here. We have our energy formula, 4.18 times the mass. Remember, the water mass is going to be 195, so we're going to multiply that times that, and the temperature change. The temperature change of the open cup was 1 degree Celsius. So we have 4.18 times our 195 grams times our 1 degree Celsius. So, let's see here, 4.18 times 195 times 1 equals 815.1, and it told us to round to the nearest 1 degree. So it's the same thing as 815 joules. Okay, we're going to use that 815 joules. Over here on the top of the page is the energy, right? So we're going to put that 815 joules there. Our area, which we calculated on the other side, remember, 0.004 times 1800 seconds. So we're going to take 0.004 times 1800 is 7.2. And then we're going to take our 815 and divide by 7.2, and we get 113.19, and it says to round to the nearest 1 degree, or the nearest 1. So we're going to call it 113 watts per square meter. Okay? This is the solar constant that we've just calculated, and we're going to put that in here, divide by 1,300, so 113 divided by 1,367 will equal 0.082. Oh, we need to multiply times 100. 8.27, so to the nearest 1 degree would be 8%. Okay, so this figure might be a little bit off because our experiment was done inside with a light instead of the sun. So we would not probably want to base our next question on that, but if you were planning to install solar panels and kind of using that kind of a concept, our value would not be worth it, right? Only 8%. But if it was a solar, sunny day outside and we could have recorded this outside, we would have been able to get a clearer picture. We need to answer these 2 questions. The questions here, 2 and 3, and answer this question, and then take a picture and turn it in to me. Thanks. Have a good day.